Okay, so the last topic for this unit is kind of a standalone topic. It's from Chapter 8. It is actually one of the only things we're doing from Chapter 8, really all semester. And we're just doing bits and pieces of 2 sections, basically. So let me focus that just a little bit better. So section 8.2 is what we call arithmetic sequences. I know that's spelled like arithmetic, but you say it arithmetic, okay? So first of all, let's talk about what a sequence is in general. A sequence is just a pattern of numbers. And so we're going to talk about the 2 most basic type of sequences today. You can have lots of different patterns of numbers. So like you've been doing this since elementary school. You remember those problems in elementary school where they're like, here is the shapes, what comes next, or whatever, and you're like, oh, it's a circle next, okay? That's really essentially all we're doing here. We're just using numbers also, okay? So arithmetic sequences are specific types of sequences where the pattern is addition. So it's basically a sequence with a pattern of adding a constant. So there are some patterns where you change up what you add. That's not what we're going to look at today. We're looking at the most basic types of patterns. So you add a constant to get from one term to the next. So let's look at an example of a sequence like this, and then I'm going to show you kind of what things are going to be called. So let's say that you had a sequence that looked like 3 for the first number, 8, 13, 18, 23, and then we're just going to say ... implying that what happens with this sequence? It goes on for how long? Forever, yes. Okay. So I think we can kind of see that the pattern is pretty consistent, right? What are we consistently adding to get from one term to the next? We're consistently adding 5 to the previous number, right? So we're going to talk about what all of these things are, but skip a line under this. So when you see the term A, you're going to read this as A sub 1. Think of it like a subscript. That's why we call it A sub 1. You're going to have A sub 2. And A sub 1 is simply the first term. A sub 2 is the second term. So what do you guess A sub 3 would be? The third term, and so on and so forth. So this right here is A sub 1. This right here is A sub 2. A sub 3. That's why I told you to skip a space. A sub 4 and A sub 5. Okay? So you would keep counting up. So anytime you see like A sub a number, the number is telling you which term in the sequence you're at. So I'm going to do this right here because I don't want to list, over and over. Okay, so ... you're going to go as far as you need to, and then generally we're going to stop at some number. So maybe it's the 100th term, maybe it's the 50th term, but we usually call the general term the nth term. Just know that n could be any number. So A sub whatever just means that number term. Okay, and then D represents the constant being added every time. And D stands for difference, because the difference between, for instance, 8 and 3 is 5, right? The difference between 13 and 8 is 5, and so on and so forth. Okay, so for example 1 above, what was D? What was the number we were adding every time? 5, yes. If you're getting smaller, what kind of number do you think D will be? Negative, yes. Okay. All right, so a lot of these patterns are going to be really easy to pick out. So for this pattern, I want you to find the next 3 terms, and then I want you to find what D must have been. Sorry about that. So let's say the pattern I have is 8, 4, 0, -4, and -8. Okay, so the first thing I'd want to ask you is there a consistent pattern? Like, are we adding or subtracting something every time? Yes, right. In fact, it looks like we're adding or subtracting. Subtracting, so we don't really say subtracting, we just say we're adding the negative. Okay, so D looks like it's -4. Okay, so notice the next 3 terms would be easy to get, right? What would be the next 3 terms then? Okay, so pretty easy, right? You just take the previous term and you subtract 4 from it, okay? But what if I asked you for the 100th term? What would you not really want to do if you could avoid it to get to the 100th term? Do you really want to list out 1 through 99 and then get to the 100th? Probably not so much, right? So that is why we have a formula for the general term. So notice I'm calling this A sub n. That means any term number that I want can be found by taking A sub 1 plus n minus 1 times D. This is for arithmetic sequences only. That's the kind of sequences we're talking about right now. Okay, what does A sub 1 mean in general? The first term. What does D mean in general? The number you're adding to every time, right? So let's just say I asked you to do something kind of crazy for the one above. So for example, 2 above, let's say I told you to find the 150th term. So I don't know about you, but I don't want to sit down and list out 149 terms before this one. Yes?
Can you round a little bit bigger?
I'll try to zoom in, but I mean, okay, so if I want the 150th term, what am I going to call that in general? A sub what? 150, right? I want A sub 150. That means the 150th term. Okay, so whatever the number is here tells you what term you're on. And then what's it telling you formula-wise? You take the first term, which was 8, plus 150 minus 1, right? Because the formula is n minus 1. And then times whatever your D was. What was our D this time? -4? Okay. So if you punch this in the calculator just like it is, you're going to get -588. It shouldn't surprise you that it's negative. How come? Because what were we doing every time? Subtracting 4, and we did it 150 times, right? So like clearly we're going to have a pretty large negative number when we're done. So this formula that I put a star by, this is going to be something that you're going to need to know, okay? And it's for, again, arithmetic sequences. All right, so remember I do post all these videos online too, so if you need to go back and fill in the blanks, you can always do that later. All right, so another way we can write a formula is something called a recursive version of the formula. A recursive formula is just a formula that uses the previous term to get to the next term. Sometimes these are great because they're really easy to read once you know what you're looking at. And then sometimes they're not so great because you have to know the term before it to be able to use the formula. So the main thing I want you to get used to is how these look. So here's what a recursive formula looks like. Rather than just being a general formula like we just used above, okay, it looks like this. To get any term, we take the term before it. I know that looks weird, right? But if A sub n is, let's say n was 100, okay, then what would 100 minus 1 be? 99, right? So we'd be using the 99th to find the 100th, right? If we were looking for the 50th, we would be using the 49th to find the 50th. Okay, it's always the one before it. So I know this formula looks weird, and mainly I just want you to learn how to read it, okay? So this is how you kind of decipher this formula. It says to find any term you want, whether that be the 100th, the 50th, whatever, you take the term before it and you add what to it? 3. So occasionally you're going to see this formula maybe written like this, and again, it's just do you know how to read it or not? Okay, so try not to make the recursive formulas harder than they are. Just think of it like if I want any term, I'm taking the one previous to it and doing something to it. So if you see this formula, and then I tell you that I want you to start with -5, what am I basically telling you then? I want you to start with -5, so that's the easy one, right? So if you want the first 6 terms, I'll start you off. -5 is the first one, okay? And then what am I telling you formula-wise you need to do to get to the next one? Add 10, right? So -5 plus 5 would be, or plus 10 would be 5. And then it's pretty easy to add 10, right? And we just need to list the first 6, because that's what we were asked to do. All right, so recursive formulas are great. When do you think recursive formulas wouldn't be helpful? We kind of already talked about it today. Well, that's a good point. Yeah, if you don't know the starting point, you can't use it, okay? But you actually can't use either formula if you don't know the starting point. But it wouldn't be great if you wanted like the 100th term, right? Because then you'd have to get to the 99th term just to get that one, and then you'd have to go to the 98th term. You see what I'm saying? You'd have to list the whole thing, okay? So they're really only helpful in kind of small circumstances. Okay, so let's do one where I just tell you to write a formula for the general term. So when you see this term, the general term, okay, that means you're supposed to be coming up with a formula that would work for anything at all. So let's say this is the pattern I give you. So the good thing about arithmetic sequences is they're very easy to pick out what's going on. Okay, so what do you notice the pattern is? Yeah, we're subtracting 2 each time. Okay, so the pattern is we're subtracting 2. Okay, so by the way, that means that this is an arithmetic sequence. If your pattern is constant and you're adding or subtracting, it's arithmetic. Okay, so what that tells us is we are allowed to use that general formula. A sub n equals a sub 1 plus n minus 1 times d. Okay, and then I just need to fill in the things that I know, right? Now notice, I want a general term formula, so I'm not going to replace anything with a sub n. Like, I don't know what number I'm being asked to find, right? I'm just asked to find the general term. But I do know the first one, right? What's a sub 1? 30. Don't really know n minus 1, so I'm going to leave that alone. Okay, but I do know d. What is it? Minus 2? Okay, so then I'm just going to clean up this formula a little bit. Remember that distributive property can work backwards this way too. So this would be 30 minus 2n plus 2. If you distribute that -2, remember -2 times n is -2n. -2 times -1 is plus 2. So then clean it up and you'll get -2n plus 32. Okay. So now if I asked you to find the 200th term, you could be able to do that quickly, right, without having to write a whole list of 200 numbers. Okay, so that's arithmetic sequences. So how do we know it's arithmetic? Like, why did I say that was arithmetic for sure? How do you know it's an arithmetic sequence? If you're adding or subtracting the constant number every time, right? All right, so we're doing these together because this is the second most common type of sequence. Okay, but its pattern is going to be almost as easy to pick out. All right, so we know what arithmetic sequences are, right? We add to get from one number to the next. Well, geometric sequences are where we multiply to get from one term to the next. So here, notice we're multiplying by a constant. So maybe back, let's flip your notes back. Maybe here we'll just underline adding a constant. Okay, that's the only difference between what we talked about back here, right? Arithmetic sequences, we're adding a constant, and here we're doing what? We're multiplying by a constant. So the a sub 1, a sub 2 thing, that stays. Okay, but this time instead of D, we use the letter R. And this is the number you're multiplying by. But R stands for ratio. So where D, whereas D stood for difference, R stands for ratio. Okay, so I still think you're going to be able to pick these sequences out pretty easily. So let's just do one where I show you what a couple of these might look like. So this is an arithmetic sequence, geometric sequence. And so is this. So I want you to write both of them down, and then we're going to talk about why they're both geometric. So what do you notice is the pattern in A? Like, aren't we doing something pretty consistently? Yeah, so what are we doing to get from one number to the next? We're multiplying by what? -2, right? Not just +2, right? Because we're changing the sign every time. Okay, so we're multiplying by -2. So what that means is R is -2. Okay, the number you're multiplying by is what R stands for. Okay, so what about in part B? If you're tempted to say divide by 2, okay, that's not wrong, but the pattern is always what we're multiplying by. So what's another way to say dividing by 2 that has the same effect? Yeah, it's multiplying by a half, right? Multiplying by a half is the exact same thing as dividing by 2. Okay, so here the R is a fraction. So if the numbers are getting smaller, you're going to have a fractional R. If the numbers are getting larger, you're going to have a number larger than 1. Okay, so just like we had a formula for arithmetic sequences, if we want to get any old term or the general term, we have one for geometric sequences as well. And here's what this one looks like. So instead of a formula involving D, we don't have D with geometric sequences, we have R. So the formula is a sub 1 times R to the n minus 1 power. Okay, so make sure you write a times in between a sub 1 and R, and make sure you write n minus 1 as an exponent. Okay, so let's look at a couple of these, and again, I think you're going to find these are really easy to pick out. Just really need to do a couple of them. So let's say this is the term I give you, and I want you to find the 10th one. So we could list all 9 of them out and then focus on the 10th one, okay? Or we could use our formula and jump straight to the 10th one, okay, which is going to be easier. Now, what do you notice about these terms? Like, we're only on the 4th one, and it's already pretty what? Pretty large because we're multiplying, right? We're not adding. And multiplication works a lot faster than addition, okay? So what's this going to look like? It's going to look like first term times the R, right? And what's the R happen to also be? 5, right? And then to the n minus 1 power. Okay. Now, by the way, you are not allowed to multiply 5 times 5 because we have to do exponents first, right? And instead of n minus 1, what could I have written? Like, we know what n is in this case. What is it? 10? Like, didn't I ask you for the 10th one? Okay. So you're just going to do 5 times 5 to the 9th. So notice, I'm not going to combine those. It's not 25 to the 9th. That's the completely wrong answer. We have to do exponents before we multiply by the 5. So if you use your calculator, you still, even doing it correctly, get a really, really, really large number. Okay, and the reason you got such a large number is because what are we doing every single cycle? Multiplying by 5, right? So we're getting just bigger and bigger and bigger as time goes on. Okay, so what if I told you to write a formula for the general term for this sequence? 2, 6, 18, 54, ... So the first thing we want to make sure is, what kind of sequence is it? Okay, so you always want to at least mention to yourself what pattern you think you have, right? So what does it look like the pattern is? Multiplying by what? 3. Okay, so anytime you're multiplying by 3, what kind of sequence does that automatically mean that it is? Geometric. If you're adding or subtracting, it's arithmetic. If you're multiplying, it's geometric. Okay, and so what's our formula going to look like? It's going to look like first term times what? The r, which is 3, to the n minus 1 power. And for the same reason that I mentioned before, we are not going to multiply 2 times 3, because we can't do multiplication until we've handled what part first? Exponent first, right? So we would do 3 to the n minus 1 and mess with that, and then multiply by 2. So leave it like this. Don't multiply those out. Okay, so on the test, and we're going to look at the review here in a bit, but on the test you might be given just a random sequence and you have to figure out which of the two it is. Okay, but it's easy to pick it out, right? If you're adding or subtracting, it's which one? Arithmetic, right? And if you're multiplying, it's which one? It's geometric. Okay, yes, what's your question?
So for like number 2, we say find the 10th term, that's when we actually like solve it, and then for the general terms, like we look for the formula.
Yeah, but I mean, honestly, we used the same formula to find the 10th term. See what I'm saying? We just actually plugged in a number. But when you see a find the general term, it's just going to be a to a sub n type formula. Like, it's not going to be a solid answer. Yeah. It's just going to be a formula that could get you the answer if you wanted to. Okay, so last thing I want to talk about, because this is going to be on the review, I want to make sure that we know how to do percentage increases with geometric sequences. Okay. So some things increase not by the same amount every time, but by a percentage rate. So if you have an increase of 4%, okay, what that actually means is we're going to use an R of 1.04, and we're going to talk about why. The reason we're going to use 1.04 is that would be the same as 104%, right? And so an increase of 4% means keep the original 100%, right? And then add what to it? 4%, right? So keep the original 100%, okay, plus an extra 4%. All right, so let's look at an example like that, okay? So let's say that you make 30 grand your first year at your first job outside of college. And let's say you get a 3% raise each year. Okay, so if you stick with this job, my question is, what will you make in the 15th year? Okay, so what's the thing about percentage raises that you can think about? Is it going to be the same dollar amount you're going to get a raise by every time? It's not, right? It's going to depend on what you were making, right? So it's not going to be a solid constant number every time, okay? So we're gonna use R equals 1.03, okay? And why are we gonna do that again? What did I say this really means? 103%? Okay, so if I want to know what I'm going to make in the 15th year, then what am I trying to find? A sub 15, right? So let's use our formula. It's not on screen anymore, but what's the formula for geometric sequences? You take the first number, which is your first year salary, right? What were you making first year? 30,000. And then you're going to multiply that by 1.03 raised to the 15 minus 1 power. Let's see what that ends up being. Remember, we're not going to do 30,000 times 1.03. We're going to let the calculator do exponents first. Okay? So it's going to be 30,000 times 1.03 raised to the, basically what power are we raising it to if it's 15 minus 1? The 14th power, right? So notice we end up making $45,377.69. Okay, that's a lot more than you started with, right? But it's not crazy more because you're only getting how much percent each year? 3%, right? Which is kind of a small amount. Okay, so I almost always have students make the mistake. Okay, so while you're kind of finishing that up, let me move my calculator, sorry. I want you to see what happens if you do what a lot of people do, which is they forget that they need to use 1.03 and they just use 0.03. Okay, so I want to talk about what's happening. Okay, you're getting really ripped off, right? Because what are you actually saying your salaries, what's happening to your salary if you leave the 1 off? You're making 3% of what you did the previous year, right? You're not getting a raise of 3%, you're making 3%, which really sucks, right? Which shouldn't surprise us why we get this crazy small answer. By the way, that e to the negative 17 means we need to move the decimal place 17 spaces. It's a very, very tiny decimal because what did you do by accident? You said every year you were getting reduced 3% of what you were making before, right? When we actually wanted to do what? Increase it by 3%, which means we have to have 1.03. Okay, so it's probably like the biggest mistake that I see on geometric sequences, so just kind of a heads up about that.